All right, y'all, so this is 9.5 support. And this is just going to go over what we call the rules of exponents. So the first exponent rule we got is what we call the product rule. Of our exponents. And the product rule tells me if I got two variables being multiplied. You know, we've been doing this all year. We've been multiplying variables. So remember, when you multiply variables, you added those exponents. Second exponent rule is the power rule of exponents. So the power rule is when I have something inside parentheses with an exponent raised to an exponent outside them parentheses. So what we do when we have an exponent raised to an exponent, we multiply those exponents. We have a quotient rule of exponents. So this is when we're dividing. So if I got an a to the m divided by a to the n. Well, when we're dividing the variables that have exponents, we subtract the exponents. And it's always the top exponent minus the bottom exponent. And y'all, the last one deals with negative exponents. This is called the negative exponent rule. So in math, we're not allowed to keep exponents negative. When we write our final answers, the exponents have to be positive. So if I got a variable with a negative exponent, I basically treat the a like it's got a 1 under it, and I flip it, which gives me a 1 over a to the n. Also, if the variable is in the bottom of a fraction with a negative exponent, we're going to flip it also, but that moves it up to the top and makes the exponent positive. So y'all, the moral of this story is on the negative exponents, if it's up top negative, we move it to the bottom, make it positive. If it's on the bottom negative, we move it to the top and make it positive, okay? So I'm going to go through the 5 problems in support that deal with these exponent rules. So the first 3 say multiply and simplify. Now, also number 1 is a x to the 5th times x to the negative 7th. So the first thing we're going to do, we're going to invoke this product rule up here that says that I add exponents in this case. So basically, I would come in and do my 5 plus that negative 7. All right, well, 5 plus negative 7 is going to give me a negative 2. But y'all remember, I cannot keep that exponent negative. So I'm going to follow this negative exponent rule that tells me if my variable's up top with a negative exponent, I'm putting under a 1 and making that exponent positive. So this would give me 1 over x squared. Okay. And then nothing else I can do to that. So that's our final answer on that one. Number 2, I got a z to the negative 5 times z to the 8 times z to the 7. All right, so I got the same variable with 3 different exponents, but they're being multiplied. So I'm going to add all 3 of these exponents. So that's going to give me z to a negative 5 plus an 8 plus a 7. So now we're just going to add all 3 exponents. So negative 5 and 8 give me 3. 3 plus 7 give me 10. So I end up with a z to the 10th. Guess what? That exponent's positive, so I don't have to do anything else to it. We're done. So notice, I'm only going to flip them if they're like this first one and I got a negative exponent. All right, y'all, look, this one's got parentheses. 9c to the 3rd times 3c squared. All righty. Following order of operations, this multiplication in the middle is going to be the last step. We got to work each of these terms first. Nothing I can do inside the parentheses, so I've got to go to the exponent next. Now, the first thing you want to do, everything inside parentheses, you want to make them have an exponent of 1. So now, I'm going to remember I got exponents raised to an exponent. And up here we said when you got exponents raised to exponents, we're going to multiply the exponents. So I'm going to bring down my 9. 1 times 3 makes that a 3. On the c, 1 times 3 makes that a 3. Now I'm going to, so I just distributed my exponents by multiplying. I'm going to do that on the second parentheses now. So I had 3, 1 times 2 gives me 3 squared. On my c, I have 1 times 2, which gives me a 2. All right, so what I'm going to do now is figure out what 9 to the 3rd is. So 9 times 9 times 9 is 729. C to the 3rd times 3 squared. 3 times 3 is 9. So that's going to give me 9c squared. So y'all, my last step is to figure out what that 729 times 9 is. That gives me 6,561. So remember, I had to multiply the numbers, but y'all, what would I do to this? I got a C3 that I got to multiply by that C2. What will that give us?
C5.
C5. There you go. So although up here we had to multiply, we were using the power rule. Down here, we added them because we was using the product rule. All right, y'all, so let me try to...
Can you go over that one more time?
Okay.
Right.
So on this problem?
Yeah.
Okay, so... Oh, let me do one similar to this again. Let me do another number 3 for us. All right, let me get my camera back up here. So this would be another one like 3. So say I had 4c to the third times 3c squared. So remember, the first thing you got to do is try to work inside the parentheses, but y'all, we can't do nothing in this parenthesis or this parenthesis. So following order of operations after parentheses, I go to my exponents. So I've got to play with this exponent 3 here and that exponent of 2 here. So to finish this one off, I treated everybody like they had exponents of 1 since none of the stuff inside had exponents, treat it like a 1. So to work this exponent, we're using the power rule because we got exponents raised to an exponent. So basically, we're going to start by distributing that 3 inside the parentheses. So I brought down my 4. 1 times 3 gave me 3. I brought down my c. 1 times 3 gave me 3. Then I got my multiplication. I'm going to bring down this 3. 1 times 2 makes that a 2. And then I'm going to bring down that c. 1 times 2 makes that a 2. So I used the power rule when you got exponents that follow those parentheses like that. So now I just figured out, at this point, I'm just going to figure out what these two numbers equal. So 4 to the third, 4 times 4 times 4 gave me 64 c to the third. Over here, 3 squared would be 3 times 3, which gave me 9c squared. So now at this point, I'm going to multiply these numbers together. So 64 times 9, that gives me 576. But now remember, I'm multiplying these variables now. A c to the third times a c squared. That goes back to the product rule of exponents, the very first one I gave you. And it said when I multiply variables, I'm going to take these two exponents and we're going to add those exponents. So that I came down and had my c, 3 plus 2 gave us 5. So that's the trick on those, is just really following that order of operations, okay? All right, so this number 4 here, it says divide and simplify. So for 4, they're giving me a y to the 9th over a y to the negative 9. Well, this is division, so we're going to use the quotient rule of exponents. And the quotient rule of exponents says that you're going to bring that variable down. You're going to take the top exponent and subtract the bottom exponent. So y'all, that's going to give me 9 minus a negative 9. So when the bottom exponent's negative, you're going to get that double negative. So what's that going to do?
Make it positive.
We're going to make that a positive. So basically, this is a 9 plus 9. And y'all, that gives me what? A y to the 18th. The exponent's positive, so I'm done. I don't have to worry about anything. Only time I'm worried about flipping this is if that exponent's negative on that final answer, okay? All right, and then this last one, it's going to say simplify. And then they tell you, write the answer using positive exponents only. So for number 5, I got a 4x y to the 4th all squared. So y'all remember, Can't do nothing inside of parentheses, so we're hitting this exponent next, order of operations. The 4 needs a 1 by it, and the x needs a 1 by it. The y has a 4 by it. So to get rid of our parentheses, we got to distribute that 2 times all the exponents inside. So remember, when you got an exponent following parentheses, you multiply it by all the inside exponents. So that 4, 1 times 2 gives me a 2. My x, 1 times 2 gives me a 2. And then my y, 4 times 2 gives me an 8. And y'all, the only thing I can do at this point is take care of what this 4 squared is. Anytime you got a number to an exponent, they're going to want you to write it out as being evaluated. So we got 4 squared, 4 times 4 would give us a 16. And then bring down your x squared and your y to the 8th. So that is our exponent rules, okay? Now we're going to get into 9.5 college algebra, and we're going to look at properties of logarithms. And they're sort of similar to these exponent rules, because remember, ain't a logarithm basically an exponent? So they sort of mimic them, but they're not exactly like them, okay? So let me get my paper ready. So we will look at 9.5, properties of logarithmic functions. And these properties are definitely going to help us tomorrow when we start solving those equations. So let's look at the properties of the logs. And y'all, I'm just going to call them logs for shorthand, so I don't got to write that logarithmic thing out, okay? First property is the product rule of logs. And this tells me what to do if I got a product. So if I got a log base A, M times N, that can be written as a sum of these logs. A log A M plus a log A of N. And I always remembered that because the product rule of exponents says when you're multiplying the same variables, you added the exponents. So that sort of keeps me in line with this. And I got a product, so I'm going to rewrite them as a sum of logs. Second one is the power rule of logs. So y'all, the power rule says if I got a log base A of M raised to the N exponent, I can rewrite this as a product of the N times the log A of M. So basically, when you're dealing with logs, we're not allowed to leave exponents in a log. So basically, all I do is bring the exponent down to the front and rewrite it as a product. So if they say anything like rewrite as a product, that's what they're wanting us to do. Bring that exponent down to the front. Hey, and then we had what, a quotient rule of logs? So that would be if I had something like a log base A of m divided by n. So y'all, let me ask y'all this. When I was looking at exponents and I had that fraction, what did I do with those exponents?
Subtract.
I subtracted them. So guess what? The quotient rule of logs is the log A of the top minus the log A of the bottom. So the quotient rule is rewritten as subtracting the logs. All right, y'all, I got one more property, and this is called the log base property. If I got a log base A of A to the M, well, y'all check this out. The power rule tells me I would bring the M down to the front, but then I got the log A of A behind it. A log base A of A part equals 1, remember? Anytime this base matches that result. So when you bring the M down, M times 1 is just M. So y'all, if the base of the log matches the base of the result raised to an exponent, that answer will be that exponent. So these are the properties we're going to follow as we work these problems. And what they do, they give you pairs of problems, some doing logs and one doing an ln for each of these properties. So this one says, express as a sum of logarithms. Well, the only property that had me write anything as a sum was this very first one. It's the product rule, which means they're going to give me a product like this, and I'm going to write it as a sum. So y'all, number one has a log base 17 of 17 times 289. Now, basically, remember, you got to distribute that log to both of your terms here. So for this one, we would get a log base 17 of our 17 plus the log base 17 of our 289. Now, although that would go further, we don't have to, because all they wanted us to do on that was write it as a sum, okay? So notice, you're distributing your log 17 to both of the factors, and you're putting that big old plus sign in the middle, okay? Now look at this one. They got an ln of C times D. So, remember, ln is just a log base E, but they're just getting you used to the different logs on this one. All we're going to do is distribute that ln to both factors, and in the middle, put a big plus again. So we're going to get an ln of our C plus the ln of our D. So that's not too bad. You're just writing it as adding, okay? So then the next one they say, express as a product. We all look up here. The only thing expressed as a product is this power rule stuff. And all I did was bring the exponent down to the front and wrote it as this product here. So watch this for number 3. They're giving me a log base b of a y to the 14th. Now, y'all, let me show you. Although they got parentheses here, that's really a log b of y to the 14th. They're just throwing parentheses to separate the letters and stuff. But the only thing I got to do is take that 14 and bring it down to the front so that I get a 14 times the log b of y. Now, you didn't have to get rid of parentheses like I did. You could have just took that 14, slid it out to the front and been done, okay? Just remember, we're not allowed to have exponents after the variable when we're doing a log. So, y'all, I got a challenging one here. I got an ln of the 6th root of a 7. So guess what? The exponent's hidden because we don't know what the exponent is yet because they got this big radical here. So y'all, I'm going to recall y'all on something real quick. I'm going to recall y'all on how to turn something from a radical into a fractional exponent. So I've got a radical here. N represents the root of the radical, like the 6 is in this problem here. And then A to the M underneath. To rewrite this as a fractional exponent, you take the A. The exponent goes to the top, which will be the M. The root of the radical goes to the bottom. That's how you convert from a radical to a fractional exponent. And remember, this is the root of the radical in the notch, and tree roots go to the bottom, okay? So, y'all, I'm going to bring down my ln. I'm going to bring out that 7. Now, let me ask you this. Notice right here, what was under the radical, I had an exponent here. You see this 7 under here. It don't have an exponent. What would the exponent automatically be under here for that 7?
1.
It is definitely a 1. So if we rewrite this as a fraction like we got over here, the 1 goes to the top, and then the root of that radical goes to the bottom. So a 6th root of a 7 is the same thing as 7 raised to the 1/6 power. And y'all, guess what? All we did on that step was convert out of that radical. Now, write this as a product. We're going to take that exponent and bring it to the front so that I get a 1/6 times my ln of 7. Now, you're going to get good at these because I got like 4 or 5 problems today where we're going to convert out of them little radicals, okay? So guess what? The next 2 expressed as a difference of logs. And if we're going to express them as a difference of logs, we're going to use the quotient rule because it's the only one that's got anything that looks like a difference on it, okay? Now remember, it's always the top minus the bottom, just like it was with the exponents a while ago, okay? So for our number 5, they're giving me a log base t of P divided by 4. Now, y'all, we'll say the thing they're going to be picky about in this section, capital letters, you have to write as capital letters. Lowercase letters, you got to write as lowercase letters, okay? All right, so we distribute to log T and rewrite it as subtraction. So we're going to have a log base T of our P minus the log base T of our 4. All righty, then number 6, they're going to hit us with an ln again. ln of m divided by n. So y'all, one of y'all want to tell me what that's going to give me?
ln m minus ln n.
Perfect. Good job. So, all you're doing, division, subtraction, be good, okay? So now they're going to start sort of mixing some of these up on us, okay? So y'all, let's turn over and we'll see what they want on these. I sort of like these little log rules once I got used to them, you know, so. Takes a little getting used to, but once you get used to them, they're not bad. Now check this out. These will say rewrite as sums or differences of logs. So this is where we're going to sort of turn it up a little bit on you, okay? So y'all, for number 7, we got a log base C, and in parentheses, I got a x squared, y to the 7th, and a z. So let's think about this. I've got stuff being multiplied in here. So this stuff being multiplied, are you going to write that as sums or differences?
Some.
Sums, there you go. So we're going to distribute the log C to all 3 of these factors, y'all. So we got a log C of our x squared plus a log C of y to the 7th plus the log C of that z. But y'all, let me tell you this. We're not done on this one yet. There's something else I could do to that.
Add the exponents.
I got to get them exponents. Good job. So remember, we can't have these exponents up here behind the variables. So if it's got an exponent, we got to pull that exponent down to the front of each of the logs. So y'all, the first one would give me a 2 times a log C of x, plus the second one gives me a 7 times a log C of y. And then the last one I couldn't do nothing with, so that just brings down my log C of a z. Final answer. And I'm not going to lie, that's going to be used a lot where you bring them exponents down, okay? So y'all, let me show you a nice one, and we like to test you on this one. So you might put you a little star by this number 8. Because you'll probably see it on a test in your lifetime, okay? I got a log B. And now I got a fraction here, okay? On top of my fraction is a P3 Q5. On bottom, I got a M3 and a B8. So here's the thing when you rewrite this one. The factors on top will be positive. Because remember, they're being multiplied on top, so they're going to be rewritten as a sum. So they'll be positive. The factors on bottom well, remember, it's like this stuff is being subtracted when they're on the bottom. So the factors on bottom will be negative. Follow that every time. Anytime you got a fraction, the factors on top will be rewritten positive, which is added. The factors on bottom will be subtracted. I'm going to distribute the log B to all 4 of these. So I'm going to start on the top. I'm going to have a log B of P to the 3rd plus a log B of Q to the 5th. So notice, both of them are positive on top. My last 2 factors are on bottom, so they're going to be subtracted. So I'll have minus log B of M to the 3rd minus my log B of B to the 8th. So, what are y'all doing next?
Bringing the exponents around to the front.
There you go. On 3 of them, I'll do that. But y'all remember that last property I gave y'all? For the logs? I had a log base A of A to the M. In the long run, this log base B of B to the 8th. So watch this. Log base B of B to the 8th. In the long run, that part is just going to equal 8, okay? Remember, if the base of the log matches the base of a result raised to an exponent, that answer will be 8. And y'all, it's because of this. If you bring the 8 down, you'll have 8 times log B of B. Well, guess what? Log B of B is 1. So that's 8 times 1, which gives me that 8. So that's why this stuff equals that exponent, and that's it. So 3 of these are bringing exponents down, and then that's going to be a minus 8 at the end. So we have 3 log B of P plus, what's that, a 5 log B of Q minus the 3 log B of M minus 8. So you got to put an 8 there to be in the most simplified form. And y'all, everybody's will have a number at the end when y'all do them in math lab, okay? All right, so then you know they like playing with that LN stuff. So here we go. LN of 7 divided by 6 x to the 6th y. Y'all, once again, I will follow this rule that says if the factors are on top, they're positive. Any factors on the bottom will be negative. So when we distribute our LN to all 4 of our factors, ln of 7 on top is positive. Then it'll be minus the ln of the 6 minus the ln of the x to the 6 minus the ln of the y. Can we go further?
The ln x to the 6th.
There you go, y'all. So I get to rewrite all this just to move that little 6. All right, y'all. ln of 7 minus, or ln of 6 minus 6 ln of x minus ln of our y. I'm getting y'all ready for calculus now. I ain't doing all this ln stuff and logs, okay? This is what y'all do in a pre-calculus class, probably. All righty, so 2 more good ones, and then it sort of switches going the other way. So y'all watch this one. Log square root C5D. So the first thing I'm going to do, we got to take care of this little radical. So I'm going to put the C5D in parentheses. And I'm using parentheses because all that's under that radical. And when I rewrite that radical as an exponent, it's got to affect everything, okay? So y'all, let's see this. That radical, what exponent is that going to give me? There's not a number in the notch. Anytime there's not a number in the notch, we treat it like a 2 for a square root, right? So a square root always has a 2. So if you're going to rewrite this one as a fractional exponent, so say I had my a under here, this would give me a. Remember, there's no exponent here, so you treat the top number like a 1. There you go. So square roots are written as a 1/2. So I put my C5D in parentheses, and out here I'm going to put my exponent of a 1/2. Now, before I rewrite as logs and stuff, I've got to take care of this exponent. So when I had an exponent raised to an exponent, what did I do to those exponents, Walgo? In support.
You multiply them?
I multiplied them for sure. So the D, I'm going to treat the D like it's got a 1 there. So let's see. On my C, 1/2 times 5 is 5/2. On my D, 1/2 times 1 is 1/2. All right. So these are being multiplied. Am I going to write them as a sum or a difference?
Sum.
All righty. So y'all, here we go. We got a log C to the 5/2 plus our log D to the 1/2. All right. Anything else?
Move the exponent.
So there we go. Once again, moving our exponents. So I get a 5/2 log C plus what I have, a 1/2 log D. So I'm gonna do one more really nice one for you. And then we'll take our break and then we'll come back and we're going to go the other way. We'll take stuff that's being added, rewrite it as products and stuff like that, okay? So let me move back up and flip my page. So this will be like number 11. All right, y'all. So out front, I got a log base A. Then I've got a really big radical. And my radical has a 4 up in that notch. So on top, I got an M16, N20 over a A9 and a B5. All right, y'all. So the first thing we got to do is take care of that big radical. So we're going to bring down our log base A. I'm going to put the fraction inside parentheses again. So y'all, here's what I'm wondering. I got a 4th root radical here. What will my exponent be?
1/4.
1/4. Good job. So square roots are 1/2, cube roots are 1/3, 4th roots are 1/4, and so on, okay? Well, y'all guess what? We still got to simplify this because I got a bunch of exponents followed by an exponent. So we're going to multiply every exponent on the inside by that 1/4. So let's start with the M on top. 16 times 1/4. And basically, when you multiply a number times a fraction, you're basically taking the number, dividing by the bottom of the fraction. So 16 divided by 4 would give me a 4. And guess what? 4 is 1/4 of a 16, right? Then I got my N. 20 divided by 4 would make that a 5. Right on the bottom, I got my A next. I got a 9. Well, 9 times a 4th is just going to be 9 divided by 4. Can't do nothing with that. So I'm going to leave that as a 9 divided by 4. And then on that B, I got a 5 times 1/4, which is basically 5 divided by 4, which I can't do nothing with. So that's going to stay a 5/4. So y'all realize at that point, all we did was get rid of the radical, right? All we did so far was just got rid of one little radical. Now, I'm going to rewrite them as sums or differences. Remember, top stuff is positive, bottom stuff negative, okay? So here we go. Log A of M to the 4th plus log A of N to the 5th. Those are my 2 top factors. Now my 2 bottom ones will be subtracted. So minus a log A of A to the 9/4 minus the log A of B to the 5/4. Right, so y'all know the next step, right? Well, 3 of these we know the next step on. One's going to be its own unique answer. So the first one, I will bring the 4 down to the front. So I get a 4 log base A of my M. You know, the second one, I will bring the 5 down to the front. So I get plus 5 log A of N. Y'all, the third one, I'm just going to write that as a minus what?
9/4.
9/4. Because remember, the base of the log matches the base of the result raised to an exponent. The answer is always the exponent. And then at the end, A and B don't match. So I'm going to bring that 5/4 down to the front. And I get minus 5/4 log A of my B. So I'm going to let us have our break. And when we come back, we're going to go the other way. So what a way to wake up on a Thursday, right? Any questions before y'all do the break?
I'm doing them on MathLab as you're doing them, and I'm getting my numbers right and all that, but when I type it into MathLab, like 3 of them, it's like still counting them wrong, but I just think it's how I'm typing them in.
Okay, so what we're going to do then, let's do our break. And Natalie, I'm going to let you share your screen and we're going to tell you how to put that thing in there.
Okay.
That sound good, y'all? So then that, because that's a trick. Whoo, I had that last night. I think, wasn't it Michelle? We was trying to figure out some of hers, what was happening. So yeah, MathLab's really tricky on these. So let's do our break and then we'll help her put them in and we'll get all y'all fixed on that, okay? And Natalie, just have it where I can access and you can share your screen with us, okay? All right, if you're ready, you can share your screen with us. All righty, so let me just think what we'd get on that real quick. So you got a log square root A7B. So that, and if we worked it out, would give us a 7/2 log A. So let's punch this in. So start with your fraction and do your 7/2. Arrow right. Put in log A. Now, let me see. You're doing 7. Oh, that's number 10. Okay, so that's what's getting you right there. So go back and take away the A. Because the A is not a base on this one. So now put an A. And then do your plus. And then your 1/2. And then arrow out log B. So on that one, it didn't have the bases on the log, so you didn't have to do that subscript to that, okay? All righty, so let me think about this one for a second. So we would have 5 log C of M plus 3 log C of N plus the C will cancel, giving me a minus 7/4 and then minus log C of A, and that'd be a 3/4. All right, so this one you'll start out with a 5 log. Now this one does have a subscript C. Arrow right and put in your M. Then we got plus 3. Put in your log. Base C again. Arrow right and put in the N. There you go. Minus. So this one matched up with the C's, so it just ended up being a 7/4. And then arrow right, minus 3/4. Arrow right and do your log. Base C again. Arrow right and put in your A. So that helping now?
Yes. I
Okay,
saw what
so-
I was doing wrong after you had said it.
And that's the main thing you got to watch out for. Some of them, they do give you the bases, and then some of them, they don't give you a base. So it would technically be a 10 on those ones, but we don't have to write that, okay? All righty, y'all. So let me share my screen, and we're going to knock out the. Now, remember, the last few of these, we're going to go in the other direction. So these examples, let's see, am I up there? Are going to want us to express as a single logarithm. So these will start at number 12, y'all. So this one has a log base C of 49 plus a log base C of 69. So since they're being added, we rewrite this going the other way as a product. So this will be our log base C of 49 times 69. Now, MATLAB actually wants us to multiply this. So this will come down as a log base C. All right, let me see what that 49 times 69. That gives us 3,381. So notice all they're doing is starting with the sum and writing it as a product. All right, let me let one back in real quick. Now this one says, hey, write this as a single log. And then it says, if possible, simplify it further. So here we go. We got a log of 100,000 minus a log of 10,000. And you'll notice these ones are being subtracted. So what led me to doing subtraction was that quotient rule, which means we're going to write this as a fraction. The positive factor to the top, this stuff being subtracted goes to the bottom. So factor out that log. The 100,000 goes to the top over the 10,000. All right, so we can divide that. Let's see, what's that? 100,000 divided by 10,000 gives me a log of 10. So that's the first answer they want. But then it'll say, so that's the first answer they want. But then they say that simplifies into a what? So remember, this is basically, there's no number here, so it's a 10. So I got a log base 10 of a 10. What's that simplify to?
1.
A1. Good job. And y'all, that's the only one where you had to actually step it down and get the actual final answer, okay? All righty, so here's a fun one. 1/3 log C of X plus 4 log C of Y minus 5 log C of X. Now, before I try to rewrite it as a single log, I'm going to do one thing first. And the one thing I'm going to do first was usually the last thing I did in the earlier problems. Remember, the last thing I did was bring the exponents down to the front. So if I'm going the other way, the first thing I'm going to do is bring all these exponents back up behind them variables. So y'all, we're going to get a log C of X to the 1/3 plus our log C of Y to the 4th minus our log C of X to the 5th. Now, I'm going to start writing it as a single logarithm. Remember, if it's positive, it's going to go to the top. The stuff being subtracted, its factors will go to the bottom. So we pull the log C out front. On top of my fraction, I'll have an X to the 1/3. Y to the 4th. All over, the one factor being subtracted was the X to the 5th. Uh-oh. We would almost be done, but guess what? I got an X on top and an X on bottom. So do you remember what I did to simplify when I had variables on top of the same variable with their exponents? What would we do?
Multiply.
Not multiply. Remember a while ago when I had, say, an X to the 9 over X to the 4? What do we do to those exponents?
Subtract.
We subtracted them so that I got an X to the 5 out of that. So we're going to take the 1/3 and subtract the 5 and see what that gives us. So now you could do this on a calculator. I'm actually going to do it by hand real quick. Treat the 5 like it's got a 1 on the bottom. So in order for me to add and subtract fractions, I need a common denominator. And the smallest denominator between 1 and 3 would be the 3. So I'm going to have a 1/3 minus, well, if you turn a 1 into a 3, you multiply that by 3, multiply the 5 by 3, gives you a 15 over 3. So now, 1 minus 15 gives me a X to the negative 14/3. So y'all, if that X was on top with a negative 14/3 exponent, we can't keep that exponent negative. So that X would have to move to the bottom and make the exponent positive. So we're going to have our log C. Only thing on top will be the Y to the 4th. On bottom will now be the X to the 14/3. And y'all, I'll tell you a trick on this. You had a 1/3 and a 5. Since 5's the bigger exponent, the answer stays in the bottom. So this is bottom heavy like J-Lo. Anytime it's J-Lo style, the exponent stays in the bottom. If it was top heavy, like say Dolly, then the exponent would stay in the top. So the variable will end up where the larger exponent was, okay? And y'all let me see, nothing else we can do to that. So final answer. So
When
that
it's the negative 14/3, I thought to switch it from being a negative, you had to put the 14 on the bottom.
well, so let me show you what happened. So when I subtracted that from this, I would have ended up with a log C x to the negative 14/3, and then my y to the 4th. So this would have actually been on top with the negative exponent, but to make the exponent positive, remember, it's like you're flipping that, so that this, if it was on top, to make this exponent positive, I would keep my y4 on top and move the x and make the exponent positive on the bottom. So you're either moving them up or down to change them exponents, okay? All righty, so that was what, 14? Woo, here comes another tricky one, so let me get 15 ready. All right, y'all, ln x to the 6 minus 3 times ln of a cube root of x squared. So the first thing I'm going to do is convert this radical. So I'm going to bring down that ln x to the 6 minus 3 ln. Remember, I'm converting the radical now. I got a cube root of an x squared. What will my fractional exponent be?
1.
Well, remember, I used the exponent in that root to write this the fractional exponent.
2/3.
2/3. There you go. So it's always the exponent on top, and then the root of the radical goes to the bottom. So at this point, your next step would be to bring that 3 up top. Now, when you bring this 3 up top, it's going to multiply by this exponent. So what we need to do is figure out what 3 times 2/3 equals. Well, y'all look at that. The 3's cancel, making a 1, and 1 times 2 is a 2. So that's going to give me a ln x to the 6. And I'll actually write that step what I just did. So I'm going to have the ln x to the 2/3 times that 3. And we said over here when we multiplied those, all I ended up with was a 2. So y'all, you're going to get an ln of x6 minus an ln of x squared. So anytime you got a number in front of the ln and it matches the radical's index, they basically cancel out and you're left with that exponent that was on the inside. All right, so I got subtraction. So this will end up looking like a quotient. So bring out the ln. The top factor will be the x6. The bottom factor will be the negative one, which is the x squared. So y'all, what can I do to that?
Subtract the 6 and 2.
Okay, what did you just say?
Subtract the 6 and 2.
Well, you're on the right track, but remember, you don't want to times them. You want to
Subtract them.
subtract them. There you go. So that'll be like x, top exponent minus the bottom. So y'all, my final answer will be ln of x to the 4th. So y'all just remember, when you're dividing, subtract exponents. When we was multiplying earlier, we added those exponents, okay?
And if you don't have one of the numbers in the radical, like in the crevice of the radical,
Uh-huh.
you do 1 under it.
Well, this little crevice right here. So if you took a calculator and you punched that, what would you actually be doing? A square root, right? So you would do that kind of number, and what would you get? A 5 out of that? So if you see a radical by itself, it's doing square roots, which means it's the only time we hide a 2 in math. So no
So
number.
you put a 2 if there's not a number, not a 1.
Right. Because see, a 1 wouldn't do nothing to it. A 1, the first root of a 25 would still be the 25. But since square roots find numbers that were multiplied twice to get this number, like 5 times 5 was 25, it's undoing that kind of process. So we always treat that like a 2 if there's not one there, okay? Now, okay, so here's something. What if I had this? I think I might have misunderstood you. So there's a 2 here. Now there is a 1, but the 1 would be by the stuff underneath if it didn't have an exponent, okay? All righty, y'all. So the last one, there's 2 of these. So this one says ln of x squared plus 12x plus 27 minus the ln of x plus 9. Y'all, if you notice at the moment, ain't nothing I can do inside either one of these parentheses. So I'm going to rewrite subtraction as a quotient. On top will be my x squared plus 12x plus 27. The factor being subtracted, the x plus 9 goes to the bottom. All right, y'all. So we got to simplify this. And the only way to simplify this, since I got a factor of x plus 9 on bottom, the only way to simplify it would be if I got a factor of x plus 9 on the top. So to see what we're going to get on top, we're going to factor that. Now, there's nothing you can do to the x plus 9 on the bottom. So y'all watch this. We got an x squared. That's going to be an x and an x. The last number is positive. So both of these factors will have the same sign as the middle. So both of these will be positive. So y'all, the trick is, can you find me factors of 27 that add to get a 12?
9 and 3.
9 and 3. And y'all let the bottom guide you. Because if it's going to cancel, one of these factors has to be a 9, right? All right, well, guess what I can do to them x plus 9s? I can cancel them right out. So my final answer, and you have to keep this in parentheses, would be a ln of x plus 3. Just like they wrote this ln of x plus 9. When you got 2 terms, they got to be in parentheses when you have that ln out front, okay? So 16, you're going to factor cancel and write what's left. All right, so I'll let y'all catch up for a second. Then I got one more for you.
I feel like I'm gonna have a lot of trouble with these.
Well, follow these notes, okay? Because y'all are going to go in the same way. All right, y'all. So let's see. 17. I'll tell you the tricky part's going to be because you got all these radicals and stuff you got to convert. All right, y'all. Same thing, but this one is a log of x squared plus 9x plus 8 minus a log of x squared minus 1. So once again, nothing I can do in the parentheses. So it's being subtracted, so we're going to write it like a fraction again. So bring out that log. The top will be the x squared plus 9x plus 8. The bottom will be the x squared minus 1. And y'all, let me tell you on this one, since you got an x squared up top and an x squared at bottom, they will both factor. So let's play with the top. Then we'll come in and play with the bottom. So on top, I got an x squared. That'll be an x and an x. The last number is positive, so both of these will be positive like the middle. So y'all, I need factors of 8 that equal 9.
8 and 1.
8 and 1. Now y'all, watch what I do to the bottom. There's an x squared, so that's an x and an x. The last number is negative, so one of these will be positive, one of these will be negative. Now notice, there's not an x in the middle, so it's like a 0. So what factors of 1 subtract to give me 0? And you only got one guess.
-1, +1.
There you go. So basically, when you do this one, bring down the x and the x, and then the square root will be a 1 and a -1. If you have a 4 here, you'll have a 2 and a -2. A 9 will be a 3 and a -3. It's basically the square root of that number that's going to be put into both sides, okay? So the question is, what can you do to that?
Cross out the x plus 1s.
Yeah, x plus 1 on top matches the x plus 1 on bottom. Now, this one, since it's in the form of a fraction, we don't have to keep the parentheses. X plus 8 on top, x minus 1 on the bottom. Because when it's wrote as a fraction, the log applies to the whole fraction, okay? So y'all, that is what we call the properties of our logarithms.
If ours don't cross out, do we just write the whole thing?
Oh, yours is going to cross out. Are you doing one now that don't cross out or something?
Yeah, I have the same one as you on top, but mine just says 64 instead of the 1.
Oh, okay, so watch this. So your top, you got an x squared plus 9x plus 18 over x squared minus 64.
Just plus 8, not 18.
Oh, okay, that's plus 8. Okay. All righty. So watch this. My top, what's going to factor in the same thing I had, right? At x plus 8 and an x plus 1. So here on the bottom, you got an x and an x. One will be plus and one will be minus. Now, think about this. What factors of 64 subtract to give you the 0? Because there's not an x in the middle. So basically, what number times itself will give me 64?
-64?
Well, let me ask you this.
I mean, well, 8 and 8 give you
Okay,
64.
that's what I want. 8 and 8. 8 and 8, that's the same number, right? So you're looking for whatever number times itself equals this last number. Okay. Which will be a +8 and a -8. Because y'all, what you're doing, you got to treat this like it's got a 0 in the middle. And you're finding factors of that number that'll subtract to equal 0. So when you break down all your factors of 64, oh Lord, what are there? There's a lot of them. 4 and 16, and then the 8 and 8. Only one set of factors gave me a 0, and that was that 8 and 8, okay? So make one positive, one negative, and guess what? The 8s will cancel out so that we end up with the x plus 1 over the x minus 8. All righty, y'all. So any more questions?
Not for this.
All righty. Well, I knew you had one on some word problems, I think it was. And all righty, so that was today's lesson 9.5. So I will send that out in a little bit. So I'm going to stop my recording real quick.